So thank you, Norbert, for this wonderful meditation time. And now we feel relaxed as a family. So I'm representing here GRAME, Musical Creation Center from France, Lyon. And here's Michel Buffa from University of Côte d'Azur. So we are here to present you our new Faust IDE and how to develop WebAudio plugins with it. So Faust is not just another programming language. It's the programming language for very complex DSPs. So Faust is a functional, synchronous, domain-specific programming language designed for real-time audio processing and synthesis since 2002. And Faust is also a multi-language code generator, which will allow you to export DSPs for many other audio platforms just using the same code. So recently, our GRAME team and with Karma guys, we developed a lot of robust DSPs in Faust, such as physical modeling or simulations of analog devices. So these are all open source. So if you want to use them, just learn Faust. So if you are using Faust for writing for other platforms, you may need to download a Faust compiler, then install it. So it's just a little bit complicated. But if you are writing for web, just for web audio, this specific target, thanks to Mscripton and LLVM, we have a WebAssembly version of our Faust compiler that allows you to do everything on web, just in the browser. So this is our workflow. If you have your Faust source code, you will have it compiled with our WebAssembly version of Faust compiler. You will get the DSP function with its UI structure, as you can define, can have description of UI structure in the Faust code. Then with a node wrapper and the UI generator, you will get your audio worklet or script processor Faust node with its HTML UI. Since 2015, this is all done, and everything could be done just in web. So we have made a previous version of Faust Online Editor, which allows you to write code in browser, to run it, and hear how it sounds. You can play it with a UI or MIDI devices. But when I am learning Faust, I'm like saying I need to know every detail about my DSP and my signal, and I need to know exact values of each samples. So I need to visualize my signal. This is why I developed this new version of Faust IDE. So let's take a look. I will show you the real version, which is already online, this one. Via HTTPS, you have faust.gram.fr/IDE. So this is our default code if you can everything. I'll just remove this reverb, and in our code editor, you certainly have code highlighting, you have hinting, linting, you have documentations here. So our process here is Pulse generator that output and a 1 each 10,000.
Zoom,
I
zoom.
will zoom a little bit. Yeah.
Oh, too much. Like that?
Maybe.
Okay. Is it better?
It's better. Every 10 million, 10,000 samples, it will output a 1. It is connected to a physical model of string, a blocked string. So you have arguments like frequency, strike position, strike sharpness, gain, and the trigger that we omitted because we are controlling it with our pulse generator. So let's run it. It works. I will mute it for now for explaining what's on our layout. So we have small file manager that you can do multiple files at once. And as Faust supports file import and export, you can have your library here and just do import certain libraries. You have you have one important button here, which is export, that allows you to, if you are not writing just for web audio, you can export to multiple platforms. We have like VST, like pedals, like iOS for phones, like everything. So you can adjust many options about web audio node generations. You have a bunch of options related to how you visualize your code. I will show you later this. And on the right side, you have all about audio, all about inputs and outputs. You can choose your MIDI, physical MIDI import, or just using a computer keyboard to simulate it. You have audio file, which can play as a loop. But it's not used here in our case of DSP. You have two small probes to probe your signal quickly, and you can start record our signal output. We hear it in real time. And I click on save. Okay. So I have my signal now. I can drag and drop here to set it as audio input. And to test it, I will just import a reverb here, reverb. Okay. So let's listen to it. Now I have my signal with reverb. Okay. Now I want to visualize it, so I can just pop up this. Okay, I can just pop up this UI to control it later. In my plot panel, now in offline mode, I can choose to continuous, more samples to visualize. We have modes, spectral scope to leave. And if I click on draw spectrogram, I can show you the spectrum here. Okay. So what I'm doing here is I want to connect my reverb to our original DSP here. And I will make a button, checkbox, which named like web audio conference. I will do multiplication, allow it to control my pulse. Yeah. So if it works. Okay, I'll just clear the thing. Yeah, because my my reverb needs two inputs, so now it works. Oh. Okay, now when I click on this checkbox, I will trigger on my DSP. So you will see here. So if you choose on event mode for plot, you will have the data when you trigger on the button. So you will just visualize when you get this on. Okay. So let's try some polyphonic things. We have polyphonic instruments example from physical modeling. Let's try guitar MIDI. Okay. I'll stop my audio input and run. Okay. It's my guitar. And I need to play it with my computer keyboard. So I need to switch my voices to 8 in order to activate polyphonic mode. Maybe I can play it now.
Be careful.
Okay, it works. So yeah, now I have my DSP Foley working, so maybe it's time to talk about WebAudio plugins.
Okay, thank you. So this is my part. So let's start again the presentation. How do you do this in full screen? Okay, like that. Okay, so the WebAudio plugin is interesting because this is something we presented during the last WAC, and it was a way to make sort of VSTs on the web, reusable components that you can use in many hosts, like I saw on 2 different pictures there. So for details, go to the paper on the presentation from the last year. So a WebAudio plugin, what is it? It's a bit like VSTs, but they must be web aware. That means loaded dynamically into host applications. You don't have to compile them. You need just to expose them in a way, and we choose to use the main key part of the web that are URL. So a plugin is a URL. You can see here 3 of our plugins in Amped Studio, a DAO, an online DAO, and they didn't have to change any line of code to use them in their host. So in pictures, what is an audio plugin? It's some DSP code, some user interface that must not conflict with the rest of the application in the web page, no ID conflicts, no JavaScript variable conflicts or whatever. And then it's better if you add MIDI control so that you can use control panels to turn your knobs or whatever, use an expression pedal or whatever. So the WAP, the WebAudio plugin format standard that we proposed is compatible with many, many languages and approaches. So you can develop in pure JavaScript, you can develop using some DSL, like Faust, like compiled from C++. So we've been working a lot with people who made the WebAudio modules that are synthesizers compiled from C++ directly. So WebAudio plugins can be JavaScript, WebAssembly code, a WebAudio graph, or whatever. So we added an advanced support in the Faust IDE for exporting directly. So what you see here on the right and on the top are plugins that I made using the Faust IDE without touching the generated code. I mean, all using the mouse. And I will demo this rapidly after that. So this thing, I made it yesterday with Norbert, I think. So this is the Faust IDE with a new tab here and a UI builder. We were a bit fed up with audio. We wanted to be creative with graphics. This is your words, Norbert, yesterday. Yes. So let me show you that. Okay. So not this one. What's happening? Yes, it's here. Okay, it's strange that it's, yeah, okay, I hope it works. So you get some DSP code somewhere, you pass it here, or you can use many of the examples from there, and when you compile them, for example, let's try this one. When you compile them, it generates a GUI that you can try. Okay, so it works. And then if you press the GUI builder, okay, it crashed. I knew that it crashed. I don't know why. What's happening? Error somewhere. Okay, let's try again. I hope. Oh, okay, it's Jerome or whatever. That does not work. What's happening here? Okay, so fortunately I have a video somewhere. Yes, so let me show that to you. And I hope that GUI builder. So okay, so I made a video just in case of this such a problem. So you just get some code, you try it. So you can use the graphic editor for customizing the user interface. So you can change the type of switches, add texture, gradients, change the police, the knobs, and whatever. And in the end, when you publish, you press the publish button here. Okay, you're publishing to a local server, and you can try it directly. This is a web page, and you can try it like that. Okay. Oh, wait, I stop this. Okay, and once the plugin has been tried here, so you can publish it to. Okay, let me stop that. You can publish it to a remote server. Oh. Yes, you can publish it to a remote server. This is my slides, okay? So we didn't have a publication, an automatized publication system, so I used Faust IDE yesterday during the demos. And then it's available in many different host applications. So we developed for the plugin developers some testers, so you can just copy and paste the URL here. And we've got also a sort of a guitar rig rack that scans different remote servers and displays all the plugins on the right with different categories. And by just clicking on them, you can assemble them and drag and drop them and delete some and choose an amplifier, guitar amplifier, for example. And we also developed a sort of flagship application that is the guitarist pedal board that I showed yesterday. I thought I could make some demos, but unfortunately the time is running out and I got some problems, some network problems. So come to see us this afternoon. We'll have a demo of the Wasabi project, and this is part of what we are presenting. And so you can reuse it very easily. So I showed that already, but you can also use in any application. Yesterday I talked with somebody who presented the DG app. So if you want to have pitch shifting, for example, just a few lines of code are required to load dynamically the plugin from this URL. And if you don't like the GUI, you can just remove the plugin.loadGUI line and just use it as a regular audio node, and you can have your own GUI interface and set the params and so on. So it's very easy to reuse. So, okay, I'm a bit sorry that I couldn't make the demo. I don't know why it crashed. I think it's a network problem. So what is interesting is that in less than 1 minute, you can have a running plugin with a GUI. And then you can spend more time with the GUI builder, or you can tweak the CSS and the HTML or redo it yourself, but you've got a working thing. And it's very easy to reuse in any application. I mean, you won't have any conflicts in your own applications because we are using web components that are completely isolated. So we are relying only on standard web components, no frameworks, no library, nothing. It's pure code. So, and also with Faust, you can find thousands of examples on the web. Yesterday I showed how we recreated the Electro-Harmonics stun phaser. That is one of the best phaser you can buy if you are a guitarist. So I started from a paper from DAFX, and then from the paper, yeah, I wanted to recreate this, so I found a paper on the DAFX conference. I found the demo online with, okay, so then I found the GitHub repo of the guy. I copied and pasted this thing. I pasted it in the IDE. I don't know where it is. Yeah, I pasted it. Okay, it's crashed on the IDE, and I generated the plugin that is here, and I can show it to you. No network apparently. I don't know. Well, maybe here. And it's all MIDI. You can have MIDI learn and control it from a MIDI platform. So this thing, I think I made it in 1 or 2 minutes yesterday, from the code to the final plugin. And let me try, maybe this thing is going to work. Yes, yes, this thing is working. So these are the plugins that we created yesterday. So this one is here. This is a host application, and you can connect it. We can add a guitar amp, and this will be my last word. Clean sound, activate the input and try. No, nothing wants to work today. I don't know why. Okay, the input is not working. I guess, okay. Yeah, so you can try the plugins here. It's usable, and I finished now, a bit late. Okay, sorry for the problem, the demo effect we had.
Thank you.
Thank you.
All right, thank you very much, Michel and Shihong. We're really tight, so we may have time for like one quick question while Yus prepares.
Yes.
Anyone has a question?
Hey, thanks for this great presentation. This looks really nice. As a part-time security researcher, I have to ask the question, how do you make sure that plugins from external sources adhere to security guidelines? Like, are they sandboxed? Do you make sure they can't make external requests? Do they have access to the local DOM and all these things? And
okay, well, what I presented is the way to produce plugins, but on the other side, if you are a host application developer and you don't want people to crash your host, this is the case with Amped Studio. We've been working with them a lot recently. So this is an online DAO, and here I'm just loading some local plugins, okay? And the way we are working with them is that first we are developing with the plugins on our own machines, trying everything so that it doesn't crash. Then we publish to their testing server, so they test it again, and then they make them public. The way it works with external plugins, they are using WebSockets in this application, not in our applications. We are connecting to our own graph, but in that case, they've got a special node, I think, that is just getting only the sound and the data. They're not mixing the code with their code. So this is what they choose for third-party applications, and it works with that latency. So this is maybe one part. Except of that, with the first code, all the source is open source. With all the plugins we generate, we include the original source code. And you can look at it, so it's just pure web components. So we are not doing malicious stuff. But of course, if you don't take care of when you're reusing your plug. But the problem might arise also with compiling or with any other sort of methods for integrating other people's code.
Any other question? You?
No, about this DAW editor,
Yeah.
Is it free? Is part of your work as well?
No, it's a commercial DAW made by people from Amped Studio, and one of them is Jerry Clemola, that came regularly to the WebAudio conference. It's been created by researchers at the beginning, and they found investors, and they decided to go on the WebAudio for commercial applications. So. No, it's not free. Yeah, it's free for use, but it's not open source.
Okay.
And they've got a premium plan or something like that. But I don't know the details of their business model.
Mm-hmm. Okay. No, I was asking.
Yeah, but you can try it. What I just showed, you can try it, but without our arms, because it's still in development. It's still a prototype. But it works. Instead of that, what we are developing, and can show you that, is that we are developing a rack That is a sort of guitar rig for. This is a plugin, by the way. What you see the wall page, and then you can assemble plugins like that. All these plugins have been made with the Faust IDE, nearly without touching any line of code. Most of them we didn't touch any line of code, and then you can try them. Okay, let me just. Okay, it's just for debugging this stuff. Okay, this thing is not public yet, but the other one, when I played guitar, it's public, all the testers are public. All the links are in the presentation, by the way. If you click for example, if you click on that, you got the application here. And it's open. It's open source, and it's on the web, too, with all the plugins, including Norbert's plugin we created yesterday. And the WAC plugins, for the moment, they are still online. We created this yesterday during the presentation, the demonstration. Okay. I think
right.
we are already.
Thank you very much.
Okay.
Thank you, Speaker.